Test. Hello, everyone. Could you please anyone confirm that you can hear my voice clearly? All right, thank you. Let's wait for a few more minutes. Yeah, and then we will start. What time is it now? Hello, everyone. I think we can start now while waiting your friends. Probably some more will join us later. So good evening if you are living in the Southeast countries, and good afternoon and good morning otherwise. So today we will discuss about the vector stacks and queues. We will continue the discussion that you already probably watch on the video on the e-learning. And we will discuss a little bit later about your request from the last webinar that we had last week about the update that I got from Mark as the module coordinator for this module. Okay, you're with me again today. My name is Mo, and we will discuss about vectors, stacks, and queues. All right, let's start our discussion with vectors. So for example, as I'll give you some short summary about the vectors that here what we discuss about the vectors as the abstract data structure. So it's not related to any specific language programming. So what we are discuss here probably will be different with the vector that you probably already know in R or in Java or in Python, etc. Because what we are discussing here is the abstract data structure of the vector. Let's say that we have a vector phi with length 3. Okay, we have vector phi with length 3. It means that we have element 1, element 2, and element 3. So as you can see here, because we have vector phi with length 3, so of course we have 3 elements. And some operation that can be performed on this vector is we can check the length of the vector, and then we can choose any element of the vectors, and then we can store any new value to this vector to the specific index based on the index that we take from the vector. Some properties of this vector is this vector can be finite. It means that the number of element can be counted, or this is countable. It means that, of course, it's fine if you have the empty vectors or the number of the element is just 0. And the length of this vector is fixed. So if we already have the vector phi with length 3, it means that that's fixed already the size. So you cannot make it being 2 or 4, etc. The question is, if we actually need the vector with length 4 or with length 2 or with length 5, etc. So what can we do, right? So what can we do? We can, because as I mentioned, the vector length is fixed. It means that we cannot delete, we cannot add a new element. So what we can do, we can create a new vectors. Oh, sorry, before that, yeah, this is the question that I asked you earlier. So what happened if we need more elements or probably less element that the provided vectors that we already have? So what we can do, we can create a new vector with a fixed length. So for example, we can assign the new element to the original vectors that we already have into the new vector that we want. So the vector phi with length 3 but we want, let's say, vector A with the number of element 4, you can assign all the elements of the vector V, and then you can add a new element to the vector A to have 4 elements instead of 3. Or you can completely make a new different vectors. If you want to have a new vector with length 4, but with the completely different element from the previous vector that you already have, so what you can do, you can create a completely different vector. Okay, let's see. We have vector V with element 1, element 2, and element 3. And then we want to have a vector W with 4 elements. So what we can do, because we want vector W to have exactly the same first 3 elements like vector V, so we can assign each element of vector V to be the new element of vector W. That's why we call this operation to assign the first element of vector V, the second element of vector V, and the last element of vector V to the new vector W. So what happened about the element 4? Because we do not have the fourth element from the vector V, so what we can do, we can just insert a new element to the vector V corresponding to whatever the value that we need. So, okay. Yeah, so for example, here I give the element is A. All right, so the pseudocode of that, if we create a new vector with length 5, and we call this loop starting from this loop with index I starting from 1 to 5. So we can assign each element 1, element 2 until 5. And then if I have this expression, the last one, the question is, what is the final value of X? Any idea? If I got this pseudocode, and then what is the final value of X? Anyone?
It's 4.
Yes, it's 4. It's quite simple one because the index I starting from 1, 2, 3, 4, and 5, and then we collect the fourth element. So we call 4. That's correct. And let's continue the discussion about the stacks. Excuse me. Okay, so stacks also the data structure that allows us to do some operation. The first operation is insertion or adding a new element. And we can have another primary operation, which is removing the element. However, we need to differentiate between stacks and another data structure about queue that we will discuss later. So what is the specific of the stacks is the element that can be deleted is the most recently inserted or the most added one. It means that you can imagine if you have like stack a pile of books, right? You can collect it from the top until the bottom. However, maybe you will ask me, no, if I have a pile of books, I can take it any books from the top, from the bottom, from the middle, etc. Right? However, you can imagine like stacks, it could be, okay, for example, you still have a book, but you have like a specific box with the specific size, like similarly to the books. And then you just put the books like in a pile, but inside the box. So you have no other way to take the books instead of from the top, right? Because you already have specific box with books that you pile from the bottom to the top. So that's the illustration of the stacks. You can only access the last element that you inserted, or it will be the last element that you can take from the stack. It should be the last element that you add, right? So the principle of the stacks is last in, first out. So whatever the element that you insert or that you add the last, that should be also the element that you can access to take it out or to remove from the stacks. That's what the principle of last in, first out or LIFO. Okay, some operation that we can perform onto stacks is first push. This is insert operation. It means that you insert a new element or you can add a new element to the stack using the operation push. And then pop, this is remove or delete operation that take no argument. If you just do the operation pop, it will automatically delete or remove the last element that you inserted. And also top, it should this one we can use it to see what is the top element or the last element that you inserted. So like in the pile of the books that I illustrate inside the jar, so it should be the very top element or the last element that you inserted to the stack. And size, we can use it to know the number of elements of the stack. And it's empty, it will return to the Boolean argument to see if the stack is empty or not. Yeah, so this is the example like I told you. It could be the pile of coin inside the tube, pile of the books, etc. Yeah, so that's the specific theory of the stacks. So for example, if I have defined the stacks that I called S, and I got the element 12, 9, 6, and 5. So here S dot top, I can see that the last element is the fourth element, which is the value is 5, right? And then if I have another stack with this element 12, 9, 6, 5, 7, and 13, the first element until the sixth element. So the sixth element, it should be 13. So the operation relevant to this stack, the original one, we only have 12, 9, 6, and 5, right? But then we got 7 and 13. So what we can do, we insert the element 7 to the stack using the operation push. And then we got a new one, 13, using the same operation push to the stack S with element 13. Okay, another example. Let's see, we got this one. And we could remove the 13 element from the stack. So we can use the pop operation on the stack. So it will remove the last or the most top element of the stacks. In this case, it's 13. Because we remove 13 from the stack, it means that now the element 7 becomes the very top element of our stack, right? Okay. So let's see that we have stack with an element, let's say the first, second, until the end. And we have attribute as the top. This is like the index to know the last element that we inserted or the most top element in the stack. So if we say the stack S, it means that the stack consists of element from index 1, 2, 3 until n. So here, if I call the operation, the expression S1, it will be the first element of the stack or the very first element that you insert to the stack, or it could be, if in the pile of the books, our book, it should be the very bottom element. Yeah, S dot top, it should be checking the last element inserted onto the stack. And S dot top, if equals 0, what will happen? It means that the stack has no element anymore, or it's empty. Yeah. So now we can use the operation to check if the stack is empty or not. We can use is empty, right? So if the stack indeed empty, it will be true. Otherwise, it will be error, showing the error. What will happen if our stacks, it's actually only have n elements, but we check the top? For example, we have 10 element, and then you check s dot top as index 11. We only have 10 element, but you want to check s dot top in index 11. What do you think will happen? If the stack is empty and then you want to check this is empty or not, and then you call it pop, for example, there is no element to remove, but you perform operation pop, of course, it will be error, right? Because there is no element to remove, but you apply the operation pop. But what will happen if the opposite, there will be an error as well? Yeah, because if you want to check the top element of the stack that we only have 10, but what you want to check is 11. Of course, there is no 11 element, right, on the stack because we only have 10. So what will happen is we call this one overflow, but in our pseudocode, we just ignore this stack overflow if this is exceeding the number of elements of the stack. Of course, it will be error as well. So for example, if this one, we want to check if the s.top equals 0, it means that our stack is empty. If indeed the stack S is empty, of course, this will be true. If not, it will be false. And the push element, the push operator, if we have a stack S and then we want to push element X, of course, the element X, it will be after the top element, and then you add 1 by using the insertion operation that we call push. It's similar, but with the pop S, because our operation pop S, it doesn't take any object. We just use the pop S and it will automatically remove or delete the very last element that you inserted to the stack. However, if the stack empty, as I mentioned before, there is no element in the stack, but you want to remove the element of the stack using the operation pop S, this will be showing the error. Yeah. Otherwise, if the stack is not empty, of course, it will take removing from the very top element of the stack. All right, this is the example that I got from Goodreads book. So if I have stack with 4 objects, this is the original stack with 4 objects, 1, 2, 3, 4. But if we want to insert an object 5th to the stack, what is the operation do you think that we can apply?
Push.
Yep, that's correct. We just push element 5 to the stack S. So now the last object, if you want to check S.top, this is the index to check the last object of the stack. And then we can access this element as 5 because the top element now is not 4, but 5. This is the one that we just push. Okay. Now, if we have stack with 4 objects again, yeah, 1, 2, 3, 4, but we want to have the stack with element not 1, 2, 3, 4, but I want 1, 2, 3, 5, and then 4. So what is the operation?
Pop.
Yeah, we can do pop first, and then if we do pop, we only have 1, 2, 3, right?
Yes. Then we will push 5.
Yes, that's correct. We will pop first, and then the 4 is gone, but we want 5, so we push 5, and then we push 4 again because we want to have 1, 2, 3, 5, 4. Yeah, so basically that's what we can do. Why we cannot just insert 5 between 3 and 4? Again, the operation in stack, we cannot like insert between element like this because the only element that we can remove from the stack, it's only the last element that we inserted. So what we can do, we need to pop the 4 element first, and then we push 5, and then we push back the element 4. All right, this is some summary of table operation on the stack. Yeah. The operation is push 5. Of course, the stack will contain 5. Push 3, it will be 5, and then 3. And then if you want to check the size, of course, this is 2 because we have 5, and then we have 3. And pop, because we have 5, and then we have 3. Remember that the very element that we can access, we want to remove if the top one. This is the last one that we inserted. It means that if we do the operation pop, the element 3 will be gone. So it remains the element 5. So if you check if you check is empty or not, of course, this is false because we only remove element 3, but we still have element 5, right? If we want pop again, the last element is now 5, the 5 is gone, and now the stack is empty. Because this is empty, if we want to check is empty or not, yeah, this is true because this is indeed empty. Empty, yeah, because we already remove all the element. Now, again, because we have empty stack, if you do the operation pop, because there is no element to remove, of course, this will return error. Yeah, it's actually similar. What you need to do if I have push 7, so I have 7, and then to have this one, I push 9, and then to check to check the top element of the stack, it will be 9, or you can check the last element that you inserted. And then if you have push again, element 4, you will have 7, 9, 4. Now the size is 3. And then if you pop, the 4 will be gone, etc. Something like that. All right. Let's see the illustration here. So the illustration that I gave you earlier, remember that I told you there is a box to put the books like exactly, not exactly the same, but a little bit bigger than the size of the book that you pile in the stack. So this is the stack is still empty, but now I have element 5 onto the stack. That's why I push 5. Now I have element 3 as well. So this will be push 3. And if I apply the operation size, it will show the value 2 because now we have two elements, 5 and 3. Now what happened if now I check the next stack is just 5, the 3 is gone. So we do the pop. And then if you want to check this is empty, it will return true or false.
False.
Yeah, because this is not empty yet. Yeah. So yeah, not empty yet. So it will be false. But if we pop the last element, which is 5, it will be empty and will go back to true if we check using the operation is empty. And if we do the pop operation, of course, this is will be resulting in error because there is no element to remove. All right. So the first stack we have 7 as the element, and I push 9, so I have 7 and 9. I push 4, I have 7, 9, 4. With now the total element is 3. Because 4 is gone, it means pop, etc. Yeah. I think it's quite clear for this one because the primary operation is just push and pop. And the secondary operation, maybe size is empty. And the top to see the very last element that we inserted to the pop. Okay. So this will be exercise. So who can help me what operation that we can perform to have from the first stack onto the second? Yeah.
So
Hamna,
in
please.
first step, we did push 10. Then in
Mhm.
second step, we did pop 10, and then we did push 14, then push 18, and push 12.
Mhm.
And then in third step, we did pop 12.
Yes. Is there any more operation?
If you want, we can check is it empty or not.
Yes.
But
And we
I
can
don't
check if we want, yeah.
I think was
Also,
is empty.
mhm. And we can check the size as well if we want. Yeah,
Yes.
very good. I think it's clearly understood already. Okay.
Sir, I
Now,
have one question.
yeah.
Like the examples we are doing, in which we know the values, but what if someone give the stack and just give us the length of the stack and say that that we have 5 elements in a stack, but we don't know the numbers, what number is in like in length 1, in length 2, in length 3. So
Mhm.
how we will able to just push and pop the, like we will use, how we will use the length for the pushing and popping the elements from the stack?
Yeah, unfortunately for that, what we can do first, we only can check the last element by using the top. And after that, if you want to see the previous element, we need to do the pop, and then we can check the top again, to do the pop, check the top again to see what is the element of each element from the first,
No,
the second, and three.
I think can we use the length to for pushing and popping without knowing the elements? Like we just want, we have a question that you have
Mhm,
to push the third element of the
mhm.
stack. So can we use like this, push s dot length 3? Is it a function, or maybe is it a command for this thing or not? Or we have to
Oh,
just search for the like
yeah.
top and then
Oh,
whatever?
I see. But if you check any element from something instead of the specific number, that's what you said.
Yes.
Yeah. So it depends. Because like I mentioned earlier, because the stack, this is not specific to the language programming. This is like
Mhm.
general. So if you combine to check like the specific value from, let's say, from another stack or from a vector or whatever, depending on the language programming, yeah, you can.
Okay. So I just want to know how, what would be the syntax for that?
Sorry, what we
What would be the syntax for that? Like how we will write the command for this?
Yeah, you need to define the first before the stack to take the element that you want to assign to the third element, the fourth to the stack. Yeah, you need to define it first. Like for example, if
Okay.
you sorry,
Okay. Okay. Got it.
uh, do you understand or?
Yes. Yes. I understand.
Okay. Yeah. Let's see. Do you still remember the conversion from the decimal to the binary? Anyone
Yes.
familiar with this one or no one? I mean, sorry, not no one. Maybe someone is not familiar how to convert the decimal number to binary. So I suppose you guys familiar, yeah, or at least like you experience how to convert. Yeah, so the decimal place, like what we usually use every day, that's the decimal place. With the binary, we only have 0 and 1. That's why it's called binary. And then, okay, that's good. Everyone is familiar. Okay, let's see. Now we do the conversion problem using our theory about the stacks. So the idea first, each element in the stack, it should be the power of 2 because we want to convert the integer in decimal place to the binary. The binary number always can be written in terms of 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, etc. Right? Like in our decimal, for example, 230, we can write 2 times 10 to the power of 2 plus 3 times 10 to the power of 1 and so on, right? So it's similar with the binary. So the idea, that's the first idea. The second one, every time we divide the number, as we can see, because we want to change it to the binary too, we push the remainder of the element. For example, if you have number 5, and then you have this to convert the number to binary 2, you divide it by 2, it will have remainder 1, right? 5 divided by 2, the remainder 1. So we push that remainder to our stack. So this is the basic idea here. Okay, so let's see this one first. Sorry, let's see this one on the table. Anyone familiar with this one? So for example, I have 561, and then we divide it by 2. We got 280 with the remainder 1, right? And we do it divided by 2. This is the result. This is the remainder divided by 2, and so on until the last one that cannot be divided by 2 anymore. So because this is binary, like I mentioned, we only have number 0 and 1. Yeah. So we read it from the bottom, 100011 and so on. This is the integer in the decimal base. So I can write 561 with 10 base as 5 times 10 to the power of 2, it means 500, and so on. We already convert this decimal number into the binary base. So we already have 1, 0, 0, 0, 1, 1, 0, 0, 0, 1. This is in base 2. Like I mentioned earlier, that this number, because this is a binary, we can express them in terms of the number 2 power something, right? Maybe it's not quite clear how I say this is in English. What I say, it's like, for example, the 5 times 10 to the power of 2, because we're starting from 0, 1, and 2. This is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why I have 1 times 2 to the power of 9. If you calculate this one, you will get the original number 561. If not, it means that there is something wrong in the conversion of the decimal base to the binary base. Yeah. So what we push here is just the remainder of our operation. So let's say if, sorry, yeah, so we can write 561 in base 10. We can write it as 100011001 in base 2. So if we, oh, sorry. Yeah, this is the flow chart from from our idea that we already discussed earlier. So we choose the number first. In this case, the number n is 561. And then we create empty stack because we will insert the element onto the stack based on the calculation as the remainder of the number that divided by 2. So we use the floor function. Anyone still remember about floor function? Yeah.
Yes, we remember.
Yeah, that's good. Okay, the floor function. So if I have number 4.2, because this is the floor function, it will be equals 4, right? Yeah, so if we check the floor function, it's not equal 0. Yeah, if not equal 0, so we do the push and mod 2. This expression and mod 2 mean what is the remainder if the number n divided by 2. The example like 7 divided by 2 equals 3 with remainder 1, right? So we push 1 onto our stack X. And then we continue with the new number n as the floor n divided by 2. If yes, because n over 2, the floor function is equals 0 already, so we push that remainder 0. Of course, the stack is finished because it's 0 already. Yeah. So if we change this flowchart to the pseudocode, we will get something like this. Yeah. So probably in your final exams or something, you will give some specific problem like the conversion problem, and then you will be asked to write the flowchart and the pseudocode for the specific problem. It should be something like that. So it will be helpful if you try to do some exercise based on the video that you watch on the e-learning or some quizzes that you already tried on the e-learning. Yeah, based on our example that we already discussed earlier, the n is 561. And then we create a new empty stack that we call x. And then we have the floor function. This is example if we have 280 with the remainder is a half, because this is floor function. We have 280, and then we do the next operation until the last one, like I mentioned in the table, until we got the remainder 1, because we want to convert this number into binary 2. Yeah. So if you do this, and then you will get this one. So the very top element, the last one that we inserted, it should be 1. If you remember the table that we got earlier, this one. Yeah. So this is the top one. Okay. We still have one more to go, which is Q. The difference with the queue, if you imagine you come to the train station or to the bank and you want to talk to the customer service, you need to queue, right? So it will be madness if you come late, but you will be serviced first, right? That's why in the queue, using the principle first in, first out, because if you queue first, of course you will get served first and then you will be out first. So it's different from the stack, that the last element that inserted, it will be the first element that be removed from the stack. But in the queue, it's a different principle. Okay. Yeah, for example, this is the queue of the people to buy the ticket. Of course, this is the first people to come, or the first element that inserted to the queue. And of course, it will be the first element to be out as well, because this first element, it will be the element that can be performed in the queue, or that can be operated in the queue. Yeah, another example is this one, because this is called queue and there will be three elements here. So the first, the second, and the third, it will be observed like this, will be served like this. And then the next one, the call 4, it will be here, and the call 5, it will be here. So it's using the principle of the queue. Yeah, some operation is NQ. This is just inserting or adding element at the end of the queue. If you remember, the queue is from the front and then from the to the back. So if there is a new element, it will be at the very back, right? At the very last. The queue is to delete the element, and the first element to be deleted, it will be the element at the very front, or the first element that added to the queue. Yeah, this is just the operation to see the first element without removing the element. The size is to know when the number of the element of the queue, and then it's empty. Again, this is to check whether the queue is empty or not. Okay, so this is the example. We call the tail is like the very last element that come to the queue, or if the example I got you, the people in line to buy the ticket, the very last person that coming, that we call tail. In this one is 12, and this hand, the first element or the head is 7. Of course, there are 5 elements, and the location of this 5 element is 7, 8, 9, 10, 11. If you ask what about the first element, the second, etc., it's probably already removed, or in our illustration about the queuing people to buy the ticket, that's already served already, so they are gone. So this is the last people in the queue, or the last element in the queue. Okay. So as you can see here, we in Q17, 3 and 5. Remember, we already have this one, right? And this one is gone. But what will happen if we have more people coming to the queue? Of course, it will fill in the next queue, which is 17. And then if there is more people coming, or there are more elements, 3 and 5, we NQ again. So this is 3, and then this is 5, and so on. Yeah. So this will be served because this is now head. And then this, and the last one will be 5. Yeah. All right. Yeah, this is the Q15, because do you remember that the head is a 15? So if we perform the operation the Q, the element 15 will be gone, will be deleted. And the new head key now is 6. Yeah, because this is the new one. Yeah, this is the table of queue operation. So like in the stack that we have push and pop, we have in the queue operation is NQ and DQ, but we also have some non-primary operation, which is size and is empty. As you can see here, it's practically similar to the to the stack, but with the different principle. If in the stack, it will be the last inserted, it will be the first out, but in the queue, the first inserted will be the first out. Okay, let's see the illustration, some operation. Yeah, 0, 1, 2, 3. This is empty. Okay, so now let's see. At the first, we have the empty queue. There is no one queuing, yeah, in the ticketing area. But now there is the element 5 coming, so we enqueue using this operation enqueue5, and then we enqueue3. And if I got this one, why this is false? We operate the queue already, but why this is false? Anyone?
Because we have element in Q3.
Yeah, because at first we have 5 and 3, right? So we do the operation TQ, 5, the element 5 is gone already, but we still have 3. So if we check this is empty or not, of course, this is false because this is not empty. Okay, if we do the operation TQ again, so the element 3 will be gone. If we check this is empty or not, it will return true. Yeah, because there is no element anymore. So what will happen this one? Now we have 7. So it will be operate NQ7. So we have that, we NQ9. And then to check the first element, it will be 7, right? And if we now have 7, 9, and 4, we NQ4. Okay, let's see this one. What is the answer?
One.
Yes, that's correct. Yeah, we have 1 and then we add 3, but then we remove 1 and then we NQ1. So the head, it will be 1. Yeah, that's correct. Okay, that's all that I can give you for today, but I got the news. I remember that last week someone request to discuss about some past exam papers, right? I talked to Mark already. He is the not the module leader for the all modules that you are taking in this session, but like the module leader for this module, and he actually has an access. He showed me that he has access to the all question, but I do not. But I requested to the Adrian already. Adrian is like the organizer of all the modules for this program, but I do not get back from him. But I already tell the request. So another mentor, probably me in the future or anyone else, will give you another webinar about the discussion of the past exam paper. The answer is 3. Oh, okay. Is it the last one? Let's see. Oh, sorry. How? Why I got? Do you mean this one?
Yes, because sir, first we in Q1, then we in
Mhm.
Q3. So one will be DQ first, then our head would be 3,
Oh,
and
yeah,
in
will be
Q,
3,
yes,
and then
yes,
will be 1, right? And then the
yes.
head, it will be 3. Yeah, yeah, that's correct. Oh, thank you very much. You noted it. Yeah, that's correct. Mhm. Thank you.
Thank you, sir.
Yeah, so yeah, I'm sorry about your request. Is there any other tutor or probably in other group that they probably discussed the some exam paper already? Are you aware of it or you heard nothing?
Right now, nothing.
Oh, okay.
Yes, subject
Because
I have a question.
sorry, yeah. Sorry, I cannot hear you. Is anyone saying something? Oh, nothing. Yeah. But yeah, I mean, I raised the issue already because you requested that some webinar will discuss some exam paper, right? If I'm not mistaken, for our last webinar. right?
Yes.
Yeah, and I requested already. I requested already to Mark. Like I mentioned earlier, I request the access, but they do not give me the access already, so I have no access. But I requested already, and he said the next webinar, if not me, probably another tutor, they will discuss about the exam paper. I mean, it's allowed, so at some point you will get it. Yeah. Yeah, if by the time maybe in the next 2 weeks you still there is no one, just let me know and then I will talk to them already. So they will arrange the schedule for the webinar. Whoever it is will discuss about the past exam papers. Yeah. But I do need your help to contact me for using the e-learning. So I'm aware that you still heard nothing. Yeah. But if you not sending me any message, I have no idea whether you got it already or not.
Sir, there was a confusion in question 10 in summative quiz.
Which quiz?
In summative quiz, week 6, I guess. Yes, week 6 summative quiz. We have a question number 10, which is quite confusing for most of the people. So can we discuss it?
Oh, to be honest, I do not check the question yet. Is that in learning?
Sorry,
Is that from the e-learning?
e-learning. It's on Coursera.
Yeah,
The
I mean,
summative
oh,
quiz.
sorry. I used to call that e-learning, sorry. Yeah, the
Okay,
Coursera,
okay.
I mean, the online one. Is that from there?
Yes, week 6.
Question 10, week 6. I will write this down and I want to make sure that you can access the weekly greeting that I post in our group, right?
Yes.
Yes, okay. Yeah, I will post it there. I will check the question first and then I will post it there and then we can discuss if still there is either probably the question wrong or there is some misunderstanding or whatever, we can discuss it there. Yeah.
Okay.
Yeah. All right. Anything else? So if you have any problem or whatever, oh, I cannot access this, I cannot access this, I'm supposed to have access this, just let me know. I will help you to contact either Adrian or Mark. Okay.
Okay.
All right. I think that's all for today. Thank you very much. I hope you enjoyed the learning and keep fighting, keep motivated to do this module, and I hope you got the best. Thank you very much. See you next time. Bye-bye.